Hi everyone, let me welcome you to the fourth session on C programming. So in this video we see how a user can write the C functions, how the user can put us header files in his own directory. Today's speech is organized in your learning outcomes, overview of C functions, then the declaration and definition of C functions, then we some simple example like a function for the area of a circle, then how we call the function from the main code. In the last presentations we told you we have the main code that is calling many other functions. Then we will see a simple function for temperature conversion. It's a modification of the program we have seen in the last video. Then calling functions from the main code. Then how to use user-defined header files. In the first or second video, we have seen how I use system headers like stdio.h, where it is stored. It is stored in, that it is stored in /user/include in a Linux machine, in my Linux machine. But you can make your own header files and keep it in your own directory. How we do that? Then the summary of understanding. So what are your learning outcomes? First, you will learn the structure of a C function. Then you will learn to write C functions. Then you will learn to include C functions as header files into main C programs. Then you will distinguish between the usages of system headers and user-defined headers. When I look at an overview, C is designed to program in a modular style through the use of user-defined functions. I told you, it is not wise to write a code that exceeds a screen length. So if your code exceeds a screen length, it's a ballpark way of saying. If your code exceeds the length of the screen, that means you desperately need functions or class, or you have to rewrite the code somehow. So what in the main program you have to see is a main function calling, say, 4 or 5 functions. And those 4 or 5 functions may be calling several other 4 or 5 functions. Those 4 or 5 functions may be calling other set of 4 or 5 functions. So we have to program C in a very modular fashion. Then a function is a self-contained program segment that carries out some specific well-defined task. You write a function maybe for computing the solution of an equation, or maybe you write a function to convert a temperature in Fahrenheit to degrees Celsius, or something like that. It is a self-contained program segment that carries out some specific well-defined task. Then it stands as an entity which the main code can call at wish. Okay, it is sitting there, your code, the function, user-defined function, you are sits like a tool in your shelf. Whenever the main program needs a use of this tool, it simply calls it. Just like the way you take a hammer from your shelf and do some work. When you always don't carry your hammer with you. So whenever you want to do some manual work, you have to you have to take the hammer from your shelf and use that. So a function acts like this hammer. Now it's wise to decompose any program into small functions. Now, how do you declare and define C functions? A function declaration tells the compiler about the function name and how to call the function. Okay. A function declaration tells the compiler about the function name and how to call the function. So a general form of the function declaration is what is this function returning, whether it is returning a float value or an integer value or a long value or something. That return type should come here. After doing 1 or 2 exercises, you will be quite familiar with this. Then the function name, the default main function is, the default name is main. But you can have your own names for the user-defined function that shouldn't be in main. A function name. Then the parameter list. These are the arguments going into a function. Suppose you want to compute the tangent of a float value, then that float value should go into the tangent function. So likewise, I have a parameter list, that is the arguments that go into the function. So this statement is ended by a semicolon as usual. Then how the function is defined. The first you have the declaration that the return type should be there. How the function is defined. The return type, what the function is returning, whether it is a float value or int value or a character value or or an array or whatever. So this then the followed by a function name, then the parameter list as usual, then followed by the body of the function. These are set of C statements that is executing the task that is to be performed by the function. Now let us look at the function for the area of a circle. I want to compute the area of a circle. So this function name I give it as a area circle. So you can give any name. I give the name area circle. Then what is the argument of the function? That's the radius. So I have to give the radius into this function, and the function should return the area of the corresponding to that radius. Now what is going into this function is the radius value. This I put as a float. So it is a float r. That's a type is float, and r radius is going into that. And what should this area circle return? Because it is computing pi r square, I am giving in the r as a floating value. So what it has to return is a float value. So this is a return value, whatever is returned by the function, that is a float. Area circle, name of the function. Then in this bracket you have the you have your argument, that is a float type argument. Now whatever is these are the set of statements. This is a definition. These are the set of statements. So they come within braces. It is wise to put it as an indented block. So I have a float a that is the area inside this thing. You have to understand that this r and a are local to this function. Okay, the radius and area are local to this function. So I declare an area value as a, that is float a. Then a is equal to some 3.145 into r entered by a semicolon. Then this function should return something. So for that I use the return keyword, return a. So this function is returning the area as a float value. I will explain this once again. So here this function definition, if you look closely, this is the name of the function, that is area circle. This you can give any name, any meaningful name. Then what is the argument going into that? It is a radius. To this function I input my radius, it returns the area. So that r is a float value. So area circle float r. Then what is this area circle doing? It is returning the area value of area. What is that? That's what type is that? It's a float value, because I am multiplying 3 pi r square. So r is a float, so the value returned should be a float. So that's a float value. Then the set of statements are there. This function, what is this function doing? That is by it is accomplished by a set of statements. They come in a braces. They come as an indented block within braces. So how do you do that? I declare another variable a as float a. Here you can see that this a is internal to this function, so that is why I declare here. This float is coming into this function, that I declared here. This r is coming into this function, so I declared it here. This a is declared as a float. This a is 3.145 etc. into r. Okay, then return a. It has to return this function. Now, how do I call this area circle from the main code? So what I can do is I can write a main code like this. I start this with hash include stdio.h. Why do I do that? Because I have to do basic input output operations, as you have seen in the previous video. Then I have to write this function here. Okay, that float area circle float r and this statement. This the area. This is a function for the area of the circle. Okay, now I have to write a main code and call this function from here. Okay, so I have to write a main program. How do I write the main program? I say void main. Okay, then within braces I put as an indented block the code segment. What is this? This main program, what is the purpose of that? That is for computing the area of a circle. So I have to have two values, radius and area. I declare them as float variables. You can see that this radius and area are different from this, because these r and a are local to the function. Okay, this is a global variable. This float radius area, they are global variables. So what I do is I give a prompt to the user to print the area, that is printf enter the value of radius, okay, and scanf %f ampersand radius. So whatever value keyed in, number keyed in, that is stored as a floating point value in the variable radius. So that's a memory location called radius. And now it computes the area as area equal to area circle. Now here my main code is calling this function area circle. My main function is calling the area circle now. So what is it doing? It is passing this radius value into the area circle. So what does the area circle do? Area circle returns this a value computed and stores in the location area. Okay, that's another variable. That's a global variable. Now I say printf area of circle is %f \n area. Now it is printing the area. Now we will run this code and appreciate that. You have this code here, the very same code here. Now I can open a terminal here. I will close this terminal. I will open a terminal here. I will go here. I will open a terminal here. I will zoom it a little. Okay. Now I have my codes here. Area c.c is my code. Here I have my code here. Its name is area c.c. Okay. Now I can run with GCC compiler. GCC minus. GCC area circle area c dot c followed by -o some a dot out to create an executable. Now you can see that a dot out is created, and I can, without any problem, I can run the executable as /a dot out. So it asks for inputting the area. I say 4.56. It returns the area of the circle as 65.325. Okay, this is how I do that. But here one problem that you can see is, before that I will go back to my presentation. Or I can do another function. Yesterday in the last video, we have seen how the temperature conversion is done. Now those statements I put it into a C function here. So this function for performing the temperature conversion. What this function receives is a temperature in Fahrenheit scale that is converted to a degree Celsius scale. So the name of the function I gave us a temp con, and what is the argument going into that function? It is a Fahrenheit value. I put it as a float value. Okay, now this temperature converter that returns a float value, that is indicated here, a float. Okay, now the statements under this function, they are put with as an indented block within these two braces. So what is internal to this? I have to compute the corresponding Celsius value that I mark as a C as a float variable, and I have a statement C equal to f minus 32 into 5 by 9 ended by a semicolon. Then what the function has to return is, I use return C with the keyword return C. So this function will perform temperature conversion if this float value f is supplied to that. Now how do I call this function from the main code? I write a main code as hash include stdio.h. Then I write this function here, float temp convo here. Okay. Then I write a main program that will call this function temp conv. How do I do that? I write a main function as a void main, then within brace I say float fc, meaning that is a Fahrenheit value and a C value. Then I have to, the user has to enter the temperature in Fahrenheit. So I give a prompt, printf enter temperature in Fahrenheit. Then scanf the value that is keyed in, that is read as a as a floating value and stored in the variable or the memory location f. then this f is passed on to this function. Okay, so what does it do is c is equal to temp conv f. Here I have used the same values for the global as well as the local variables. fc, it doesn't matter. Now I say printf the temperature in degrees Celsius is %f backslash n c. So whatever is available here as c, whatever is stored in the memory location c, that will be printed. Now we will appreciate this code. This is my code. Here I have include stdio.h. Then I write a temperature conversion function as this float temp conv float f. Okay, and within this braces I give as an intended block float c equal to f minus 32 into 5 by 9 and return c. That is this that is this temp conv function doing. Then I have to call this function from the main program, so I write a void main. Within braces I put as an intended block float foreign cell. Here I have used different names for the global and local variables. Here I say it is foreign Celsius. Printf enter the temperature in Fahrenheit and scanf %f ampersand Fahrenheit. So whatever value keyed in, that is read into the memory location Fahrenheit, and Celsius value, that is this value is passed on to this function temp conv. So cell value is temp conv Fahrenheit. So then you print of the temperature in degrees Celsius as a floating value, whatever is in CEL. Now let us run this code and appreciate that. conv_temp.c. -o a dot out. You can run this code, this executable as ./a dot out. You can say for temperature in Fahrenheit is 32. You can see that the temperature in degrees Celsius is 0, that is, or I can say 64, 65. You can see that the temperature in degree is 18.333. Now one thing we may not like is that you see this function here. Okay, you see this function in your working space. After writing many functions, you will have to scroll through the screen to know where you are working. So it is a little cumbersome. So this is your servant who does your certain task. So you don't need him all the time. You don't want to look in him all the time. So you can, it is wise you put it in a shelf and call it whenever it is necessary. So that is when you make user-defined header files. So how do we do that? These are the user-defined header file. Having many functions in the working environment is cumbersome. You should not see this function. Once you write this function, you have to put it in your hard disk and you have to call it at your wish. Okay, you don't want to see it very often. So it reduces the ease of having many functions in this thing. Reduces the ease of programming and readability of code. So it is wise to shelf the user-defined functions and include them on need. Okay, you write a function for something, you put it in the shelf. Only when the main code needs it, you call it. Okay, so you don't want to see the old source code when you do other tasks. Okay, source code of all functions when you do other programming, because we know that a function is an entity that is a self-reliant, self-contained entity. So you don't want to see it. Once it is done and tested, you have to shelf it somewhere. Since it is not advisable to include C files, you can include it as a C file. You can see that in the first line you include a header file. You can include C files also, but often it becomes very cumbersome. It is not very advisable to include a C files. In Python programming, you can include Python modules as such. You write one Python function, save it as a .py file and include it as a .py file. There is no problem. But in C, it is not very advisable. Instead, they are included as header files. Okay. So let us observe the demo for computing the area of a circle. I will go back to this code. I will go to this area new.c. Now here I have used a header file, a user defined header file. How is this header file written? Where is my main code? I can say hash include stdio.h. In the less than greater than signs, I have this thing. This is a header file. This is a system header file included from /user include directory. Now I have included this area circle function like this, hash include area circle.h, but within quotes. This quote specifies that this is a user defined function and not a system header file. So what this does is, what this accomplishes is, then the compiler will not look into user/include for this header file. It will look into your current working directory for this header file. So how is this header file written? It is your old area circle.c file, that function you have written. Only thing is, it is saved as a header file with a .h extension. Okay, here you can see that the area circle.h. This is your self-same function you have written, float area circle float r, followed by the set of statements. Here I put as intended block, like float a is 3.14 r square, return a. This thing, instead of writing as area circle.c, I save it as area circle.h. You can see that is written as area circle.h. Now you can include this file in your area, your main code here. Okay. So here by putting is in quotes, you tell the compiler that this area circle.h is a C code that is available in the present working directory. So here, how do I write my main function? So void main float ra, these are radius and area values that are global to the main function. Printf, enter the value of radius, scanf %of ampersand r. So whatever value that is keyed in, that is stored as a floating value in the memory location defined as r, and this r value is passed on to this area circle function, now included as a header file. Okay, now you don't see your area circle.c or file in the same working environment or in the same screen. So that's less bother to you. Okay. So a is equal to area circle r. Printf area circle is %of \n a. So a will be printed. That will be the area circle. How it is this area computed? By passing the r value to this area circle.h function that is included here. Okay. Now I can go here. I can run this area new.c. I will clear this. Oh, it is area C new or GCC area new. It is area C new dot C minus O a dot out. Now the executable is created. I can run the executable as a dot out dot slash. Enter the value of I say 3.45. It returns a value 37.392807. Now you can see that the code has become much cleaner. Okay. Now whatever functions you have written, you write them as separate C files, store it as a .h files in the current working diary and include here. Okay, and call them from the main code. Now your hammer is sitting in the shelf. You don't see the hammer all the time. Whenever you need the hammer, you go and take it. Okay, that is how the main code calls the header file, user defined header file. Now these concepts you have to understand here. The user defined header file is included like the hash include. So within quotes area circle.h. Observe that the .h file is included with quotes and not within greater than less than symbol signs. Okay. So this greater than less than symbol sign is reserved for system header files that are stored in /user/include. It is possible to keep in the directory. If you have the root permissions, etc., to place your header in the root directory, you can do that. If you have permission to write your header file into user/user/include, you can include it there and include with less than or greater than. But it is in programming, it is advisable that you keep your user-defined functions away from the system-generated ones. Okay, so that it's always wise to keep it in your own directory. So it is wise to include like this with the quotes. You can see some other demo. I don't know if more demos are here. You can have this temperature conversion done here. How does it do? I include hash include within greater than less than sign stdio.h. Then I write another function for temperature conversion that I include as hash include within quotes tempconv.h. Okay. Now what is this tempconv doing? This is our old function I have written for temperature conversion, that is float tempconv float f. Within quotes you have the float c. C is f minus 32 into 5 by 9, return c. Now instead of saying it as a c, saving it as a c file, I save it as a .h file, that is tempconv.h in the present working directory. Now I call it from my main code. Where is my main code? This is my main code, conv temp new.c. What it does is hash include stdio.h, hash include the user defined function tempconv.h in quotes. Then the main code follows, that is void main. Within braces, I have float f comma c. These are global variables for the Fahrenheit and the Celsius values. Now here I say printf enter the temperature in Fahrenheit. That prompts my user to key in a value that is read as a floating value with scanf and stored in the memory location capital F. Now this value is passed over to my function tempconv, that is included as tempconv.h. It is sitting in the current working directory. So tempconv returns the floating value that is stored in the memory location C. Now I print, that is with printf temperature in degrees Celsius is I write as a 2.2 FC, so that it comes with a 2-digit precision. Now let us run this main code conv temp new.c. minus o a dot out. Enter the temperature in Fahrenheit, I say 32. Now we can see that the temperature in degrees Celsius is 0. I can say it is 65. You can see that the temperature in degrees Celsius is 18.33. So this is how you include your user-defined header files. So you have to make it a practice to split your task into small tasks. For each task you have to write separate functions and you have to write them as header files, and you keep it in the current working directory and include the main code. So if you look into the main code, what you have to see are some include statements and followed by a few function calls, say 4 or 5 function calls. Those 4 or 5 function calls may call 4 or 5 different other functions. So that way you have to branch out in a modular way. Now we come to the end of the presentation. Here in this video you learned the structure of a C function, then you appreciated a few C functions, then you learned to include C functions as header files into main programs. Then you distinguish between the usages of system headers and user-defined headers. System headers are kept in /user include in a Linux system, in most Linux systems, and user-defined headers are kept in your working directory. And that is the end of this presentation. I thank you all.